Hello. The next talk is mock it till you make it, how to verify your external mocks without ever leave unit testing, and is presented by Acosta.
Oh my god, I'm trying to tell myself I'm not nervous. Gosh, it's such an honor to be here. So let me just make sure I've got this set up. All right. How's your PyCon so far? Good? Thumbs up? We like it? Oh, okay. I'm into the enthusiasm. Yeah, so thanks for coming to my talk, and yeah, let's get into it. So hi, my name is Liz. I'm here at PyCon from San Francisco. So show of hands, who's coming in from California, Bay Area? Okay, cool, there's a couple of us. I am a film student turned marketer, turned software engineer, turned developer advocate, and my current iteration is as a developer content manager for Streamlit. If you don't know, Streamlit is a Python framework for data apps. We have a booth, go check it out. I know that this path to tech is a little bit unconventional, but for those of us in developer relations and developer relations adjacent roles, it's actually a pretty typical path to tech. I love pizza, plants, pugs, and of course, Python. But I especially love what happens at the intersection of tech and community, like here at PyCon. And I really enjoy finding ways to turn complex concepts into casual conversation. And that is a picture of my very sweet senior pug, Gary. He's at home in San Francisco, and I miss him very much. Cool. So by the end of this talk, my hope is that you will feel inspired to revisit and reconsider how you think about software testing, unit testing in particular, and that you'll also feel inspired to explore some of the tools that you get for free with Python in unit tests. In my experience, I find that there's a lot in there and it's very underutilized. And one of those tools is the mock object in unit test. With modern software development, it's almost impossible to write tests without needing to mock something. And while mock is a very powerful and flexible tool, this power and flexibility also means that it's susceptible to not working the way that you anticipate it working. So I got curious about it and I wanted to explore it more, and that's how this talk came about. So thanks for coming with me on this journey. Now that we know the who and the why of this talk, let's quickly talk about how we're going to do it. First, we're going to take a quick tour of software testing, and we're going to look at unit testing in particular, so that then we can better understand where mocks and mocking fits into the greater Python testing ecosystem. Then, with the blessing of the demo gods, we'll take a look at some demo code before getting into some questions and answers. Cool. So what is software testing, right? At its core, software testing is the process of evaluating and verifying that a software product or application does what it is supposed to do. So we all know all the benefits of writing tests, right? We know that writing tests can help us prevent bugs, it can help accelerate development and help us save money. But I think that the most compelling reason for writing tests is that it makes us better engineers. When we're sitting down and writing our tests and we're figuring out what our assertions are going to be, it makes us ask ourselves, what actually is the expected behavior of this method or this application? When we start asking ourselves that question, that's when code smells are revealed, and it may also indicate writing tests can help us figure out if we need to refactor a method or maybe reconsider our entire system design. And this is the kind of thinking that helps us push code that is easier to understand, easier to maintain, and easier to debug. And ultimately, this is what helps us progress in our careers as engineers. So getting kind of galaxy brain about it. So there's lots of different kinds of testing out there that all seek to answer different kinds of questions. And I decided to create an alignment chart of those different tests. And I've decided that unit testing is firmly lawful neutral, and that chaos testing, chaotic evil, of course. Cool. So we talked about software testing in general. Now let's talk about unit testing. Unit testing is the process of evaluating and verifying that the smallest functional units of code do what they are supposed to do individually and independently. So think about it as the different ingredients for something that you're trying to make. You want to make sure that all the ingredients are what you expect them to be. The idea being that then when we make the big thing, when we then go to the full application, if all the small parts are working, then the whole thing should be working. So what are some best practices for unit tests? A good unit test should be one precise assertion at a time. It should be independent, isolated, and controlled, so no outside dependencies, shouldn't rely on anything. A good unit test should be relevant and meaningful, so it's actually doing that assertion on the code under test. How many times have you started writing a test and you're like, I don't know, am I actually testing the code? Because I know I've been there. A good unit test should be repeatable and deterministic. So if a test should pass, it should always pass, regardless of what time it is, where it is. And if it should always fail, and if it should fail, it should always fail. A good unit test should also be automatic. You should be able to run it like after, with every build, or maybe when you do a commit or you push. So you should be able to like push a button and let them run. And a unit test should also be very descriptive. This is a place where a nice, long function name is a good thing. You want to be as descriptive as possible, not only because this will help you debug your tests and figure out why things are failing, or why they're failing, but this also can serve as documentation for people who are new to your code. They can go into your unit test, see the different methods broken out individually, see what they're supposed to do, and see how they fail. So it can serve as really good documentation. So like I said, it is nearly impossible to create a modern application that does not make some call to some kind of API or outside dependency, whether that's your own or an external one. And because we're good engineers who want to write good tests, mocking is an essential and necessary part of our testing strategy, right? It's just one of the many tools available in your testing toolbox, sometimes referred to as stubbing or faking. Ultimately, at its core, mocking is whenever you're simulating a component of a computer program or a software system for the duration of a test to avoid using the real thing, right? So we're using a mock. It's a stand-in for the real thing. Mocking is helpful in testing because it helps us isolate and control our tests, limit dependencies, eliminate additional costs, right? So if we're making API calls that cost money, we don't want to be spending that money when we're running our tests. It also helps prevent vulnerabilities because we're using a mock and not the real thing. And so you can kind of think of mocks as a shadow representation of reality, right? So we've got our little pug and he's sitting there in the cave and he's got the fire and there's the shadow. And the shadow is a pretty good representation, but it's not the real thing. So it's a mock of the real pug. And because mocks are just kind of these simulated representations, that means they can be a little bit controversial. And some of that controversy is well-earned because mocking does have its limitations. It's additional code that you have to maintain, and mocks can also fall out of sync with reality, which then renders your tests irrelevant and meaningless, which is in conflict with our unit test best practices, right? But since mocking is basically unavoidable in modern software, what are some best practices we can implement, right? Again, this bears repeating, one precise assertion at a time. Use a mocking library whenever possible. This, it's only usually for more established APIs and tools and stuff like that out there, but if it's available, I'd say use it. Mock only what you need, so mock sparingly and judiciously. Occasionally verify your mocks for accuracy, and we'll get into some, methods for doing this, some strategies for this, but where possible, maybe use a real response or record a real response and use that. Keep your mocks simple. So show of hands, who's ever run into a test that has a mock within a mock, and you're like, is this real or fake anymore? Am I testing anything? if you're starting to get to that point, then you've actually reached the best part of writing tests, which is maybe it's time to go back and refactor your code. When it starts getting complicated to write your tests, that's generally a sign that it's time to revisit the code under test and see if you can simplify it. So before we get into the demo code, let's get acquainted with some of the tools that we are going to use. So in Unittest, we have the mock class. This is a class that enables you to instantiate an object that you can create methods, attributes and methods for on the fly. So you don't have to make it beforehand. You can create this mock object and just like call stuff on it in your test. So you can think about the mock class as like a ball of clay that you can shape as you go. Magic mock is a subclass of mock, and it's basically a mock with all the magic methods built in. Magic methods are things like mathematical operations, being able to iterate through lists, and like dictionary keys. So if mock is a ball of clay that we can shape as we need, a magic mock, think of it as like a ball of clay that comes with some pre-built shapes that we can then mold the clay into. So cool. We've got mock and magic mock, so how do we use it? That's where patch comes in. And what patch does is it's a decorator or a context manager. You can use it either way. And what's saying is that for the body of code, within the context, replace a target with a magic mock. So a couple things to think about here, and we'll get into this more in the code. Because mocks and magic mock are so powerful, and because we can create these attributes and methods on the fly, it's pretty easy to accidentally maybe try to call the wrong method or the wrong attribute on something, and that test will fail, but it won't error, right? And so then that's also another case when we're rendering the test meaningless. In order to deal with this, mock comes with an argument for setting or configuring a specification. And what that specification is, or it's also called auto-speccing, what that's saying is that, hey, mock, use this real thing as the template for the mock and bind it to the methods and attributes that are available on the real thing. Don't let it do anything else. And so what's another way we can verify our mocks, right? We can occasionally make calls to the actual component, but how can we do that without reproducing code? One way to do that, Unittest has skip test available, and as you can imagine, when you're using skip, it's a decorator, and whatever the context is within it, it'll skip it. There's also skip conditionals, and that's something we can use if, let's say, we want to have multiple test environments. We have like dev and prod, and maybe in dev we want to use our mocks, but in prod we don't. We can use these skip tests to then like run the test or not run the test depending on what like environment variable we pass along, right? Cool, so now it's time for a demo. One second. So I've got this app. It's called Build-A-Pug. You supply Build-A-Pug with a name, an age, a home, and a time for dinner for your pug. The app Build-A-Pug then takes this, turns it into a prompt, and then that prompt goes off to OpenAI, because everything has to include AI now. And then we get back our pug. It's coming. Cool. And once we get our pug, we can check to make sure we can perform one of the most important pug tasks, which is check if it's time for puppy dinner. Unfortunately, it is not. But let's say we're not ready for a pug yet. We can go ahead and read up on some pug facts. And what's going on here is this is making a call to a static endpoint called dog API, which returns a JSON of dog breed specific facts. So in this case, about the pug. Cool. So let's look at some code. Awesome. Okay. Cool. So you see, I've got patch here, right? And so what's going on here is I'm using the decorator. And I'm saying, hey, Unittest, I want you to target this class. And so this is pug requests, right? And you'll notice that I am using the class from where it is being called, and that's within the pug module. This is very important because otherwise the target is going to be something else, right? So if I just put generic request in here, it's not actually going to patch the requests in the module, right? So it's important to keep in mind. That's like I've fallen into that trap before. Also very important when you're using date time, so FYI. Then I'm setting auto spec to true. So what I'm saying here is I'm saying, hey, unit test target pug.requests, and I want you to bind that magic mock to the methods and attributes available on requests for real. So we're going to run this. Cool. So you'll probably notice, so we ran all of our tests, and we also skipped 2. We'll get to that later. So that's how it works with auto spec and patching, right? But in case you don't believe me, and because you're talking about how we can verify our mocks, this is a case where we're not using auto spec, right? So we're using patch. We're not setting auto spec to true. We're saying, hey, this is our target. Let's go ahead and run it. And when we run it, we get a failure, right? And so if you're debugging your test, you're like, why am I getting this failure? Like, I know how to use requests, what's going on here. And you can, like, you know, chase your tail going around circles trying to figure out what's wrong with your test, or like why it's not passing, and maybe it's something else, you're chasing a red herring. But if you look here in the test, and what I'm doing is I'm asserting on what the mock request is called with. I'm using getResponse, which is a method that doesn't actually exist for requests, right? But because Magic Mock doesn't know this, it's causing it to fail instead of error out. So, one second. Cool. So, if we want to see what happens with the same test with the incorrect method, but this time we're using autospec. Save that. And I run it. Now you'll see that I've still got that failure, but now I've got an error. And this is what would be more appropriate in this case, right? So here's our attribute error. The mock object has no attribute getResponse because requests, which is the target that it's mocking, doesn't have getResponse. It's get, right? Cool. So that's like how you can use autospec to make sure that your mocks are staying true to whatever they're supposed to be a representation of. So, you know, next I talked about how can we use skip test, right? So let's say we're like, okay, I now want to test my application end to end, so I want to make real API calls. How can I do that? And skip test is one of those ways to do that, right? So what we're doing here is we're saying skip unless the test environment is prod. We're going to go ahead and set that here. So it's set. Let's verify. Cool. And if we run it, you'll see that, first of all, it takes a little bit longer because we're making actual API calls, right? And if you were running unit tests, you wouldn't want it to take this long because we want them to be automatic and fast. And you also don't want to have to wait on the internet, so we also want our unit tests to be deterministic. And you'll see that we ran 10 tests instead of the 8, because we actually ran the ones that we skipped. Yeah, so we covered how do you use mock and magic mock with auto-specking to then make sure that our mocks are faithful to the things that they're representing. And then we also took a look at how we can use skip test to skip test, determine when we want to run tests, when we want to skip tests, and that's how we can separate our tests into different test environments and run them accordingly. So, that actually, I have some more stuff for you. 1 second. Okay, cool. So, thank you very much for coming to my talk. I've got, of course, a couple of QR codes for you. That first code on the left, that'll take you to my website, where you can find my LinkedIn, my GitHub, all the good stuff. And then the other QR code will take you to a repo of this demo code. And in that repo, you will also find a README that has more resources on mocking and other testing strategies, as well as a tutorial I wrote that goes along with this talk. So if you want to pull the code down at home and follow along, test it out for yourself, because I know the way I like to learn. I like to actually get my hands dirty and see it work. So that's your chance to do that. And yeah, that is it. Any questions? Oh, I know. Sorry, I almost forgot. So the alignment chart is a pretty big hit with people, so I actually made some swag of it. I just made some little notebooks. I have very, very limited quantity because I didn't know if people wanted them. I didn't want to drag a bunch of them to Pittsburgh and then drag a bunch of them back to San Francisco. So come find me and you can get your very limited edition testing alignment chart notebook. And yeah, you can also come find me at the Streamlit booth. Also, I think there's like a Streamlit Snowflake thing up here. Get that QR code as well. And yeah, any questions?
I'm gonna approach here if you have any questions.
It was just that good. Who else here has a pug? Pug people? Yes. Okay, one in the back. Cool. All right. Oh, yeah?
So I used to do a lot of development with Java, and I did a lot of unit testing. And when we moved to Python, it seemed like the Python community where I work don't really do that much unit testing. Is unit testing big in the industry, and my place of work is an exception, or what? So this is more of a question for the crowd, but...
I feel like that's like potentially a controversial question. I know from my perspective, some people feel that unit testing is maybe a little bit tedious, which I think in some cases, maybe it definitely feels that way. You're like, I'm just testing this method. I know what it's supposed to do. I think that unit testing can be really valuable because if you're testing the smaller parts, then it's easier when you make changes to your code to see what might break and what hasn't broken anything. I think it's just more about getting into the habit of doing it. And I don't actually practice test-driven development, but that is a place of zen I want to get to. But I can understand how it's I just want to get in and start writing code. So that's my feeling about unit tests. I don't know what anyone else feels like.
Just by a show of hands, who here writes unit tests?
Okay. Are you have you used mock then? Yeah? Have you gotten into those squirrely situations where you're like, what honestly is going on here? Auto-spec.
I have one question. So Python has this really convenient but dirty method of writing quick tests called doc tests, where you basically put the tests in the description of your function. But obviously you cannot use the patch decorator right there. So what do you do then?
I think that's an occasion when I don't know if there's any way programmatically around that. I just imagine it's kind of like when you ask ChatGPT to write your code or write something for you, you have to go back and check it. So it's you could maybe use doc tests to get the foundational, maybe more boring stuff. And then for the more complex stuff, you're going to probably have to go in and do it by hand, which I think that can be really helpful because going back to the point I made earlier, it can actually make you ask yourself, what am I really testing here?
Hello, thanks for the talk. I recently discovered that it's possible to call instant methods of an object without first instantiating the object. You just have to pass it something for self. It doesn't really care. And so I was like, oh, maybe I can just pass it a mock. And to my surprise, everything actually worked. I just passed it mock for self, and I could call the instance method. So I was wondering, like, it felt like I was doing something wrong. Is that an acceptable use of a mock, or like what would you suggest?
I think at that point, it's like, well, what are you trying to test? You know what I mean? Like, if you're just like, I'm going to instantiate this and use mock, what are you going to use that for in your test, right? That's kind of how I would.
Maybe I should have, I should explain better. So, like, the situation would be the class is inconvenient or impossible to, like, instantiate on its own, but I would like to test some of its methods. And maybe this is an indication that the methods should be class methods, or the whole object should be restructured a bit. But in that situation, would it be acceptable to call to create tests that pass a mock to the self, the first argument, and not actually instantiate the object in the first place?
I feel like then that's testing the instantiation, and maybe, like, the idea is that Python has tested that, and, like, that it's working, and it does kind of seem like maybe not the way to ideally use mock, because you can just, like, be like, whatever your variable is equals, like, mock, and then you could put it in, use it as a spec, right? So whatever the class that you're trying to instantiate that's kind of difficult to instantiate, that could be the specification that you use to configure the mock. That seems to make a little bit more sense to me. But I don't know, I believe in code as art as well, so if you feel like doing it that way, make sure you write an artist statement to go along with it. Yeah. We have 3 minutes. Anything else?
Have you seen uses of mock that are not in a unit test or an automated test environment? Like, for example, if you wanted to run the application just you did as a demo and have a pre-recorded response for pug information.
Yeah, so you could, and it depends, right? It depends on what you're trying to test, because that's the important question to ask yourself, right? Like, what am I trying to test here? Let's say you were trying to maybe do, like, testing in stage where you're kind of doing a mix of real and then not real, because maybe you don't want it to take up the time and you want to record that. You could create, like, a mock server and then do it that way and use that instead. So I have seen it used in more kind of, what's the word I'm looking for? Not quite end-to-end testing. Why am I suddenly blanking? Integration testing, where you maybe want to mock some things and not other things, and then that would be a case where you're not using it in unit test. Does that answer your question?
Yeah, I think so.
Cool.
Also, even just in general application development, like if you're using a large application that you're working through, and you just want to be able to have somebody who's new to the project come and start using it instantly with some, like I said, pre-recorded data without configuring API keys and those sort of things on the machine.
Yeah. No, that makes sense. You could do that, yeah. Because then, like you're saying, you don't have to configure a bunch of stuff. They can just spin it up and use it alongside the tests. Kind of like when you, like, spin up, like, a test database and pre-populate it. I like the questions.
Hi. I just have kind of a general question more about unit testing. I work at a really small company. We're very limited software development resources. And so I think sometimes we view testing as like additional step that we can do, but not necessary. And so we do have a lot of tests, but I think we could take our tests and make them a lot better by adding mocking. We have a lot of API call tests and whatnot, and I would love to add mock testing, but I think it's kind of hard to convince everyone like this is beneficial and to change that idea of like this is something we should have. What would you recommend to help encourage that?
Well, they can either do it now or they can do it later when an incident occurs.
Right. Yeah.
You can tell them that. Like, do you want to work on a unit test or do you want to be paged at 3 a.m.?
Right.
Yeah.
That's true. Yeah.
That usually works.
Cool. Thank you.
And good luck. Let me know how it turns out.
Hi. We use mocks all the time at work in our unit test. I find myself coming across these tests all the time that are over mocked, and I was just wondering if you have any suggestions or tips on how to weed those tests out beforehand. So I find myself figuring it out when I'm working on the test itself, but is there a telltale way for me to find those in mass and eliminate them? Because they're just everywhere. It's so easy to overmock.
Yes. I think that what could help there, I don't know, once you have like 2 mocks in like one test, maybe that's when you're like, am I actually testing anything? There's actually on the README in the repo, there's a really good article that's like, don't mock what you don't own. And at first I was like, what does that even mean? Of course I have to mock what I don't own. But it's talking about more, so for instance, like in the pug or dog API call, I'm asserting not on like what the expected response is and a mocked response, right? Or a test response and a mocked expected response. I'm asserting on whether or not request is called with the URL.
Right.
So you know what I mean? Like that's the actual test. That's the part that I own. And as far as like how to find them in mass, unfortunately, I don't know. Maybe it's time to develop that tool. But honestly, like trust your intuition, I think. If it gets to a point you're like, this is too much now, it might be a good time to take a look at it, yeah.
Right. Thanks.
No problem.
Okay, thanks, Liz,
Okay.
for the talk. Applause.
Cool. Thank you. Yeah.